What's the deal, all my ninjas? Welcome back to another video in this journey to NRC playlist, and I thank you for clicking on the video and tapping in with your boy. I am the Network Ninja, and I'm just trying to establish a community of like-minded IT pros, just trying to all level up and train. The topic of this video, let me go ahead and get right to that. This is for anybody studying EIGRP. This is going to be talking about more specifically successors, those type of routes, right? The feasible successor routes. I'm going to be talking about that. If you already know this stuff, then maybe you can learn something from my technique or my perspective of how I'm sharing this information. You feel me? Or if I'm incorrect or there's some tips you could share with me, definitely go ahead and drop that information in the comments. Let me go ahead and get out your way. If you've been rocking with me, you already know how I do. Let's go ahead and pull up our lab, right? So yeah, let me give you the breakdown of what we got right here. In this topology, I got EIGRP is running around this whole thing. Got a whole bunch of different serial links. And right here from router 3, as you can see, we got 3 connections going over here to these 3 routers, which are leading over here. This is our destination, and we're going to just really be looking from the source right here, going to a destination network that's simulated by a loopback address that we got on R1. What we got right here, that 192.168.1.1 network simulated, that's the IP address of that network. And then on R3, we're going to have 3 paths right here, all learning that network via EIGRP. And let's get started. So if you've been studying NRC and EIGRP specifically, you should know show IP route EIGRP will pull all the specific routes for EIGRP out of the routing table, and then we're just going to filter out for that network, right? I'm sorry, we're learning 2 paths to this destination network, I should say. Path to router to that destination through router 6 and router 2, and I got everything in this lab set up. Last octet is the router number, so we got router 6, router 2. So from R3's perspective, again, router 6, road 2, I can get to 192.168.1.1. that's over here. We only have 2 paths here, but we have a 3rd path that should be showing up. It's not showing up in our routing table, so we could check our topology table and we could filter out for that again. And this should show us any paths for successors or feasible successors. So if you're taking notes, definitely drop that in your notes, that your topology table for EIGRP is only going to show you successors and feasible successors. So right here we have a destination network. We got 2 successor routes, which we know that already because any routes that are successor routes are installed into the routing table. So we have only 2 successors, and I told you already that this topology table is going to show us both successors and feasible successors. So we only have the successors here. Let's look at feasible distance, or the reasonable distance is this metric right here. As you can see, both of them have that same feasible distance. Now, on the back end of these metrics right here, you have another metric, and that's the reported distance. And that's where I want to start by breaking down the difference between reported distance and feasible distance. It really starts with the reported distance. So we got reported distance. We can see this number smaller than this number, right? The important thing to know about reported distance and feasible distance. So R3 has a reported distance to that destination network over here. The reported distance is the distance between R3 all the way through this neighboring router to the destination network. That's the reported distance. You see both these paths, to get all the way from here to here, there's cable lengths and all different things that are involved, right? All these kind of metrics and calculation, bandwidth, delay, all of this stuff is calculated into the reported distance. And then it spits out this number. So that's the reported distance. That's how the metric it takes to get to that from router 3 through router 6 to this destination. Same right here. This back half. This is the metric that it takes to get to router 2, then to the destination network. And that's why those numbers are different. Now, the feasible distance is how far is it to get to this network from the neighboring routers right here that are advertising that reported distance. These people are advertising the reported distance to this guy, because remember, this guy has no idea how to get over here. This guy and this guy do. So they're saying, hey, this is your reported distance all the way there. And that calculation is done by EIGRP. And for R2 and R6, it's saying the feasible distance from R6 to that destination and from R2 to that just happens to be the same for whatever reason, right? If you're going to talk about reported distance, I'm going to look at the source where I'm coming from and where I'm going to, and I'm going to look at all the neighboring routers through end to end, and that's going to give me, again, the back half metric. And then that front half of the metric, which is the feasible distance, that's going to be, I'm going to be looking only from whoever gave me that reported distance. So R6, you fed me this reported distance. I'm going to be looking to you for what the feasible distance is, because he's going to know how to get to that actual destination network. And that's how these ended up as successor routes. We got reported distance all the way through. That's the metric all the way through to the destination network from R3. And then you have your feasible distance, which is from the perspective of the neighboring router that's given you your reported distance. Now let's look at successor and feasible successor. If both of these routes, for whatever reason, they get taken out. If this one goes down and this one goes down, we know that this would be the feasible or the most reasonable, right, path down here. But as we can see, it's not showing up in our routing table, and it's not showing up in the EIGRP topology table. So this is in the EIGRP topology all-links table. Anyway, so let's go ahead and drop this on you. Boom. Out of serial 03, we have another path to that destination network. It is router number 5. What do we got here? Let's look at some. We just learned all of this. So the front half, his feasible distance. We're going to start there. His feasible distance is the metric between here and this destination network here. And then his reported distance, which is on the back half, is this huge number right here. And that's how much R5 is telling R3 it's going to take you to get all the way through me. It's not a feasible successor, but it is a route or another path that's not a successor. It's not a feasible successor, but it's another path that EIGRP knows about that will be installed in the routing table because it's in this topology all links table, which is going to show you all the paths to your destination network that you're troubleshooting. So if you want to get all of the paths, not just the successor, not just the feasible successor, you want any redistributed routes. This could have been a redistributed route for all you know, anything. If you want all of the paths that the EIGRP topology table has, you're going to put that keyword in your syntax right there, and it's all dash links, right? And filter out for your network. This is very key to commit to memory. To become a feasible successor, this reported distance has to be less than the feasible distance of the successor route. Our successor route is, how many zeros is that? 21,152,000, right? So I said this number has to be less than that. As you can see, we got 3. We're at 26,240,000. 21 million is less than this, so that can't be a feasible successor. That's why it's installed into this part of the topology table, because it's a path that's still there. Now, how did the reported distance get that high? That's something that I did for the lab. And let's just look at the difference between the bandwidth, because I told you bandwidth is how our EIGRP is calculating each of these routes. So if we look at, we have three interfaces, right? 0, 0, 0, 1, and 0, 3. R3 to R6, bandwidth 128. R3 to R2, bandwidth 128. Let me show you what the bandwidth has to be to generate a higher reported distance. The bandwidth has to be lower. So we got bandwidth 100, which breaks down to 100,000 kilobits, which is equivalent to 0.1 meg. 128, that's 0.12 meg. So this super low bandwidth is causing a higher reported distance, which is causing it to not even become a feasible successor, which is not even a reasonable path to your destination, but it's still yet a path. Its bandwidth is 100, but you're going to be at a crawl. But at least if these links go down, you do have another path that can get installed into your EIGRP routing table. All right, that about wraps it up for troubleshooting miscellaneous IPv4 routes, or these variations of IPv4 routes that can be in EIGRP with the successor and the feasible successor routes. We'll catch y'all on that next video. Holla at your boy. Ja.